Dear student, today we will cover superheterodyne receiver. It is called the superheterodyne receiver because of heterodyning process, which is called the mixing of signals. It is a block diagram of this. One is receiving antenna, then first block is RF amplifier, then mixer, then intermediate frequency amplifier, which is amplify the intermediate frequency. Mixer generate the frequency converter, which is the also called the first detector, and generate the intermediate frequency, which is some fixed frequency. For AM amplifier it is 455 kilohertz, and FM receivers it is basically the 10.7 megahertz. Local oscillator is a local oscillator frequency generator. Then it will provide the intermediate frequency. It will be amplified by IF amplifier, and it is given to the second detector, which is normally the linear diode detector functioning of the automatic volume control. Then it is given to the audio frequency voltage and power amplifier, which amplify the detected baseband signal or audio signals, and given to speaker, which is provide or generate the electrical signal to sound signals. So that's why it is better performance than TRF receiver, and it is the main feature is all the incoming radio frequency signals are converted in single frequencies. Various blocks are explained as below. It is called the superheterodyne receiver because of local oscillator frequency, which is mixed with the carrier frequency, which is higher than this. Then the RF amplifier, which is functioning as RF radio frequency signal amplification, also image signal rejection and rejection of the unwanted signal, so it improves the adjacent channel selectivity. And next is the mixer, which used to mix the uh, carrier frequency and local oscillator frequency and generate the sum and difference of local oscillator and the carrier frequency. Then it will provide the normally we will put this FL should be greater than by FC, then it is called the superheterodyne receiver. The next block is intermediate frequency amplifier, which is responsible for the sensitivity and the selectivity, and intermediate frequency about 455 kilohertz for AM receivers, which is amplified by the intermediate frequency amplifier. It is normally the tuned voltage amplifier. This stage provides the most of gain of the overall receiver. If we increase the more number of IF amplifier, then it will provide the good sensitivity. The next block is the second detector, which is normally the linear diode detector. Already we discussed in the automatic volume control. Then it is fed to the audio frequency amplifier. Audio amplifier, which is generally the RC coupled voltage amplifier, followed by push-pull power amplifier. First is the audio voltage amplifier, then it will be given to the audio power amplifier. This stage is decided to fidelity, and the more bandwidth of this stage, then it will provide the better fidelity. Last one is the speaker, which is generally convert the electrical signal into the sound signals. The sound signal is basically the original baseband signal is transmitted by AM transmitters. This is the overall working of the superheterodyne receiver, which is the more advantage as compared to TRF receivers. TRF receivers it provide the better performance as compared to TRF receivers. The following are the advantages. Number second is circuit design is simple due to the operate on the single converted frequency, which is called the intermediate frequency. High gain intermediate frequency provide the better sensitivity as compared to TRF receiver. It used for the medium wave to short wave range of frequencies, and selectivity is also better due to the intermediate frequency amplifier. And last one is the designing of detector is simple. It is also called the detector stage operate on the single frequency single intermediate frequency, so that's why time constant RC of the detector is a fix. So that's why designing is as compared to easy to TRF receiver. Some limitations of superheterodyne receivers are following. Number first is it is required the image signal rejection, and second is the tracking and alignment problem, which we will discuss later. Proper selection of intermediate frequency. Intermediate frequency should be proper selected. It will be discussed in the choice intermediate frequency topic, and it is also the costly. It is costly as compared to TRF receivers. So these are the advantage and disadvantage is covered in this topic. So basically in this working of superheterodyne receiver, we should require to advantage and disadvantage of this. So this is more important as compared to TRF receiver.